How to multiply hexadecimal numbers. In this tutorial, we will describe how to multiply hexadecimal numbers. In the terms involved in math operations video, we discuss terms involved in multiplication. Since we will be multiplying hexadecimal numbers, the operands involved in multiplication are multiplicand and multiplier. The result would be the product. For example, let us multiply the following. Okay, so we have a multiplicand, multiplier, and of course the product because we're dealing with multiplication. So let's look at the notes at the top first. At the left, I got 16 to the 0 power equals 1. 16 to the first power equals 16. 16 to the second power equals 256. 16 to the third power equals 4096. 16 to the fourth power equals 65,536. This is going to become helpful. Also to the top, we have the letters that are represented after the digit 9 in the hexadecimal number system. So A is represented by 10, B is represented by 11, C equals 12, D equals 13, E equals 14, and F equals 15. So for this example, we have the multiplicand, and its value is 2,575. And we have the multiplier, 243. And when we multiply these numbers, we get the product, 625,725. When we look at the value in decimal for 2,575, its hexadecimal representation is A0F. For the number 243, its hexadecimal representation is F3. Let's compute. All right, so hexadecimal multiplication is pretty much the same as what we do with decimal. So I'm going to take, it's like taking turns. Like the bottom number, we have F3. So I'm going to take 3 and multiply by A0F. And once I'm done with that, I'm coming back and multiply A0F by F. So let's compute. Let's see what we have. So let's do A0 and F. And then we're going to multiply by 3. All right, so our first computation, we have F times 3. And in decimal, that's the same thing as 15 times 3, which equals the value 45. So we want to convert 45 into hexadecimal. And that's saying 16 goes into, let me clear this up here. All right, so 16 goes into 45. 16 goes into 45 two times. 2 times 16 is 32. And when we subtract, get the value 13. And what this says is the decimal value 45 is represented in hexadecimal by the value 2D, because D in hexadecimal represents 13. So we have a D goes here. And the 2 is carried up. All right, so our next computation, we have 0 times 3 equals 0. But we add the 2 because we have a 2 at the top up here. So 2 is already represented in hexadecimal. All right, so the next computation, we have A times 3. And in decimal, that's 10 times 3. And that equals 30. And that's decimal representation. So we want to convert that to hexadecimal. And 16 goes into 30 one time. And 16 times 1 is 16. So that's, we're going to take 30 minus 16. And that's 14 is a remainder. And so that says that the decimal value 30 is represented in hexadecimal as 1E, because E represents 14. And so that's what we have here. All right, so we can move that over here because that's going to be a part of the computation. So we have D2 E1. Okay, so let's clear out for the next computation. Okay, so we can erase this and erase that and get rid of this. Okay, so we're ready. So let's convert back. All right. So now the next computation is A0F times F. And we'll put that over here so it's easy to see. All right, so the first computation is F times F, which in decimal is 15 times 15. And so 15 times 15 is 225. Oops. Let's clear that up. And then we want to convert that to hexadecimal. So 16 goes into 225. Let's see, that's 14 times. And 14 times 16 equals 224. So that means we're going to subtract 224 from 225. That's 1. And so what this says is that the decimal value 225 is represented in hexadecimal as E. That's because 14 represents E1. So we have a 1 goes here, and then the E is carried up. So next computation we have 0 times F, which of course is 0. And then we have an E to add to it, which because we carried E to the next column. So E is here, and that answer is E. And E is already in hexadecimal form, so that goes right there. And then the final computation, we have A times F, which is 10 in decimal, times 15. That comes out to be a value of 150. We want to convert the decimal value 150 into hexadecimal. So we divide it by 16. And let's see. That goes in there 9 times. And 9 times 16 is 144. So we got 144 here. So that means we subtracted 144 from 150, and that leaves 6. So what that says is that the value 150 is represented in hexadecimal as 96. And so that goes here. And so let's go ahead and move that over the computation. So 1E, just how we do it in decimal system, 6 and 9. Okay, let's clear this out real quick, and then we'll compute that. Okay, so we did the computations. We multiply A0F times 3. We added over here, and then we did A0F also times F. We came up with 96E1. So we still have to produce the final output, and we have to add the column. So we start with the least significant column. It has only D in there, so D goes here. The next significant column, we have 2 and 1. It's a value of 3. And then the next column, we have E plus E. So we have to consider this by converting it to decimal. So E is represented by the value 14. So it's 14 plus 14. And that's a value of 28. And so we want to convert that into hexadecimal. So we'll say 16 goes into 28. That's 1 time. And then 1 times 16 is 16. And then when we subtract, we have a value or remainder of 12. So this says that the value 28 is represented in hexadecimal as 1C, because 12 is represented as C. So that means a C goes here, and the 1 is carried. And so we have 6 plus 1, that's a value of 8. And then we have 9. So what we want to do is, we have an expected product of 625,725. What we want to show is that that value that we came up with for hexadecimal, that's 98C 3D, is in fact 625,725. So let's see what we have. All right, so as we did in the past, we always want to look at the position. So we have D is in the 0th position, 3 is in the 1st position, C is in the 2nd position, 8 is in the 3rd position, 9 is in the 4th position. So when we compute out here, let's see, so we have 9 times 16 to the 4th power, plus we have 8 times 16 to the 3rd power, plus we have C times 16 to the 2nd power, plus 3 times 16 to the 1st power, plus D times 16 to the 0th power. All right, so now we have to break it down even further. So we have 16 to the 4th power, we already indicated up here, is 65,536. Okay. And we have 8 times 16 to the 3rd power is 4,096. All right. So C is represented by the value 12, and 16 to the 2nd power is 256. And then we have 3 times 16 to the 1st power is 16. And D is represented by the value 13 in hexadecimal. And anything to the 0th power is 1. So let's see what we have. So we got 65,536 times 9. And that's a value of 889,824. Plus 4,096 times 8. That's a value of 32,768. And then we have 256 times 12, which is a value 3,072. And then with 3 times 16 is 48. And then 13 times 1 is 13. And then compute it up. Let's see, 589, 824, plus 32,768, plus 3,072, plus 48, plus 13. And it does come out to be a value of 625,725. And this is what we wanted to show. Next, let us perform another hexadecimal multiplication. This time we will multiply numbers with a decimal point. All right, so we have another computation, and pretty much we're going to do the same thing. So over to the right, we have our example for this example. I'm sorry. The multiplicand is 760,000 point. Hold on, not thousand. 760.5. And it's going to be multiplied by the value 14.5. And our expected value would be 11,027.25. Towards the right, we have the hexadecimal representation. For the multiplicand, 760.5 is represented in hexadecimal as 2F8.8. the multiplier, 14.5, is represented as E, 0.8. Let's compute. All right, so this time here we're dealing with decimal points. So what we're going to do is pretty much the same thing we did in the previous example, except we're going to pretend like the decimal points are not there. We'll come back to the end and consider that we have two digits behind a decimal point, and we'll have to consider moving 2 places. All right, so let's start. We have 2F 8, and then we said we start off with the right digit at the bottom, so 8 times 2F 8, 8. So we'll multiply that times 8. Let's get rid of this. Okay. All right, so our first multiplication we have is 8 times 8, which is 64. And we want to convert that to hexadecimal. And so you divide by 16 and you get 16 goes into 64 4 times. And 16 times 4 is 64. And that leaves a remainder of 0. So what this says is that the decimal value 64 is represented in hexadecimal by the value 4, 0. So 0 goes here, 4 goes up to the top. And we got, once again, we have an 8 times 8. So we know that that's going to be 64, but this time we have to add the 4 that was carried over. And that comes out to be 68. So we want to convert 68 into hexadecimal. And we do that by, let's see, dividing it by 16. And so that's the same thing. It goes in 4 times. 16 times 4 is 64. And when you just subtract 64 from 68, you get a remainder of 4. So this is saying that the decimal value 68 is represented in hexadecimal by the value 444. So we have 4 goes here, and 4 is carried over. So our next computation, we have F times 8. In decimal, that's 15 times 8. And it's going to equal 120. And we have a 4 at the top, so we have to add that. And that comes out to be the value 124. But we have to convert that into hexadecimal. And so we divide by 16. And so 124 divided by 16 is, it goes in 7 times. Oops, so let's undo that. Okay, so 7 times. And then 7 times 16 is 112. So that's saying that we're going to subtract 112 from 124. That leaves us with 12. So this is saying that the value 124 in decimal is represented in hexadecimal as 7C, because C represents 12. So C goes here, and the 7 is carried over. All right, so our next computation, we have 2 times 8. Oops. 2 times 8 equals 16. And we have to add the 7. And that gives us a value of 23. And we have to convert that into hexadecimal. And we divide by 16. 16 going to 23 one time. And when we subtract, leave us a value of 7. Okay, so what this says is that the decimal value 23 is represented in hexadecimal by the value 17. So 7 goes here. 17 actually goes there. And so let's erase so we can. Let's move this value over for we forget. All right, so over here, just put 0, 4, C, 7, and 1. All right, so that's our first computation. So let's clear this out so we can do the next one. Let's see what we have. There we go. All right. All right, we can erase this. And the guys at the top. Okay, let's compute the second one. All right, so the next one, we're going to multiply 2f88 times e. We'll do it over here so it's easy to see. All right, so we have e times 8, which in decimal is the same as 14 times 8. All right, so 14 times 8 equals 112. And we want to convert that to hexadecimal. So we divide 16 into 112. And so divided by 16, get a value of 7. And so we say 7 times 16 equals 112. So that means we're going to subtract 112 from 112, and that leaves a value of 0. So what this says is that the decimal value 112 is represented in hexadecimal by 7, 0. And so we put a 0 here and carry a 7 to the next column. So our next computation, once again, we have e times 8 is 112, but this time we have to add the 7 that we carried over, and that comes out to be the value 119. So we have to convert that to hexadecimal. So 16 goes into 119. Let's see, 7 times. And 16 times 7 is 112, so we're subtracting 112 from 119. That leaves 7. So what this says is that the decimal value 119 is represented in hexadecimal as 77. So 7 goes here, and then the 7 is carried over. Okay, so our next computation, we have f times e, and in decimal that's 15 times 14, and we have 15 times 14 is 210, and we also have a 7 that was carried over, so we have to add 7 to that. So 210 plus 7 is 217. We must convert this to hexadecimal. So 16 goes into 217. Let's see, 13 times. And then we got 13 times 16 equals 208. So that's saying that we're going to subtract 208 from 217. And that's going to leave us a value of 208 is 9. And so that says that the value 217 in hexadecimal is represented by D9. And remember, D is represented 13. So 9 goes here, and D is carried over up to the next column. So our next computation, we have 2 times E, which is the same as 2 times 14 in decimal, which would be the value 28. Plus we got to add D, but D is represented as 13 in decimal. So we say 28 plus 13 is 41. Okay, so let's convert 41 into hexadecimal. So 16 goes into 41. Let's see, 2 times. So I mean, we're going to subtract 32. And then we got 41 minus 32 leaves us with a 9. And it says that 41 in the decimal system is represented by 29 in hexadecimal. So 29 goes here. And let's go ahead and move that over because that's what we're going to add up. So this is 0, 7, 9, 9, and 2. And we'll try to make room there. So let's try to clear this out so that we can compute. Okay, so our next step is that we have to add the columns, and let's see, to produce our results. So what we'll do is always start from the least significant column. So in this column here we have 0. The next column we have 4 and 0. That's a value 4. The next significant column is C plus 7. Now C in decimal is represented as 12, and you add 7 to it, you get 19. But you have to convert that to hexadecimal. And 16 go into 19 one time. 1 times 16 is 16. And when we subtract 16 from 19, we get the value 3. So that's saying that in hexadecimal, or the decimal value 19 is represented in hexadecimal as 13. So 3 goes here, and a 1 is carried. In the next significant column, we have the value, let's see here, we have 10, so that's 17. We have to also convert that to hexadecimal. So we have 16 go into 17 one time, and then 16 times 1 is 16, and then that leaves a value of 1. So that's saying that in decimal, the number 17 is represented in hexadecimal as 1, 1. So that means that 1 goes here and the 1 is carried. 9 plus 1 plus 1 is 11, but we say 11 is represented by the letter B. And then 2 is by itself, so that's just come down. And so we want to show that our expected product here is the value 11,027.25. And what we're going to do is we have to consider, before we even do that, that this is dealing with decimals. And so we have 2 digits here to the right of the decimal point. So we start from the end here. We say here and here. So that decimal point goes there. So what this says now, 3 is in the 0th position, 1 is in the first position, B is in the second position, 2 is in the third position, the 4 is in the -1 position, and the 0 is in the -2 position. So let's compute it. So we have 2 times 16 to the third power plus B times 16 to the second power plus 1 times 16 to the first power plus 3 times 16 to the 0 power. Let's clear that up. Sorry. So it's 3 times 16 to the 0 power plus 4 times 16 to the -1 power. And of course, anything times 0 is 0. We just put 0 there. Let's break it down further. So we got 2 times 16 to the third power is 4,096. And the letter B is represented as 11. And then 16 to the second power is 256. Okay. And then we have 1 times 16. And then we have 3 times 1. And then we have 4 times... Now, 16 to the -1 power, we have it represented up to the top here. 16 to the -1 power is 0.0625. So that's what's go here. 0.625. 5, and then plus 0. So now let's compute. So we have 4,096 times 2. That's a value of 8,192. And then we have 11 times 256. That's 2816. And then we have 1 times 16 is 16. 3 times 1 is 3. And then 4 times 4 times 0.0625. That comes out to be the value 0.25. And then, of course, we have the 0 on the end. And so our final computation, 92 plus 2816 plus 16 plus 3 plus 0.25 comes out to be 11,027.25. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe division of hexadecimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also, feel free to join us at the computing sector. There will be more videos and tutorials coming soon. Thanks.